Hello, I'm Curtis Rice, District Chief with Palm Beach County Fire Rescue. Today we're going to review how to search a building with a thermal imaging camera, commonly referred to as a TIC. For this class, we will be utilizing the MSA brand of TIC to better demonstrate the subjects we will be discussing. All objects that we deal with give off heat. This heat release is in the form of infrared radiation. In some literature, you may hear the TIC referred to as infrared camera or FLIR for forward-looking infrared camera, such as can be found on the PBSO Eagle or on the Dragons at Palm Beach International Airport. Our cameras process this energy release and convert it into a viewable picture on the screen. For our purpose, we are going to take a look at three types of emitters. Each of these emitters produces a different amount of energy. That energy is what is captured by the processor and displayed on the screen, so we can see objects even in smoke-obscured environments. Let's take a look at each one. Passive emitters. These objects do not produce energy, they simply absorb it and release it at different rates based on their composition and density. Doors, windows, beds, and structural components are examples of passive emitters. These are the most difficult type to view. Since they do not produce energy, only release it, in certain conditions they can be difficult to see. As an example, consider an office building or hotel that is essentially a sealed building with an automatic temperature regulating system. If all the objects in a room are basically the same temperature and obscured by smoke, you have to be very slow and deliberate when scanning these areas. As you can see by the video, the objects are visible, but if you move the TIC too fast, you could miss something. Objects such as doors represent a vital egress point, however, not usable if you don't recognize it. Active emitters produce their own energy. Objects such as people or electronics are examples of these. With a little practice, it can be easy to see and identify what it is you're looking at. As you can see, since they generate energy, they are much easier to see than the passive emitters around them. Fire and sun are examples of direct emitters. Not only are they easy to see, they will heat up passive emitters to make them stand out also. One note of caution, do not point the camera at the sun. The massive amount of energy released can cause serious damage. From time to time, you will notice that the screen image freezes. This is perfectly normal. You may notice that a small square appears in the upper left corner of the screen to warn you of the pending screen freeze. This event occurs to automatically refresh the processor so it produces a quality image. Our TIC is designed to show certain temperatures with color to make it easier to locate the seat of the fire. Generally, the camera will show objects in the grayscale. However, in high heat situations, at the lower end of the spectrum, the colorization will start out as a yellow color, turning to orange, then to red, and finally dark red for the hottest objects on the screen. Don't get hung up too much on the temperatures of these colors. Basically, at around 300 degrees, it will begin colorizing the hot stuff. This is the high sensitivity, low heat, or normal mode. To protect the camera, once it goes above 320 degrees and a percentage of the screen is subject to colorization, the camera will switch to the low sensitivity, high heat, or firefighting mode. When this occurs, the colorization will go away until the camera sees temperatures around 850 degrees. At that point, it will start the colorization process over again from yellow to dark red. Once it gets a little over 1,000 degrees, the color again will go away. Our TICs are also capable of providing a temperature reading. The device averages the temperatures from a sampling of the subjects located around the center spot on the screen. The closer you are to the objects, the more accurate that reading will be. There are two ways to read the temperature. First is the digital readout, which is a number located at the bottom right side of your screen. Another way to tell the temperature is from the vertical gauge located also on the right side of the screen. This is a sliding scale. Depending on the model camera you're using, in the normal mode, it will go from 0 at the bottom to 300 degrees at the top. If the digital readout is 150 degrees, then the vertical gauge would show halfway up. It is important to point out that when the camera switches modes from the normal mode of high sensitivity, low heat to the firefighting mode of low sensitivity, high heat, the display changes color from green to blue, and the vertical gauge now is 0 at the bottom, but 1,000 degrees at the top. In addition to the color change, there will be an L visible in the lower left corner indicating low sensitivity, high heat. Here's what we are talking about when we compare the normal operating mode of high sensitivity, low heat and the firefighting mode of low sensitivity, high heat. On the left, the camera is operating in the normal range, as it would be when you first enter a building looking for a fire. The display is green and the colorization is in the 300-degree range. The vertical temp gauge is 0 to 300 degrees. When the screen sees lots of hot stuff, it switches to the firefighting mode of low sensitivity high heat. This protects the camera from damage. The color of the displayed items changes from green to blue, and the vertical temp gauge switches from 0 to 1,000 degrees. It has an L in the lower left corner, an indication of low sensitivity high heat conditions. It is very important to be aware of this change. If you miss the change and a tick goes into the firefighting mode of low sensitivity high heat, when the colorization returns, it's now around 850 degrees, not 300 degrees. A line at the midpoint in the vertical temp gauge in normal operations would be approximately 150 degrees. If it switches modes and you did not catch it, the vertical temp gauge is still showing at midpoint. It is now indicating a surface temperature of 500 degrees, not the 150 degrees, a profound difference. A good point to bring up here is that when the camera switches between high sensitivity and low sensitivity modes, the camera will also freeze. This is normal. It is just resetting the processor. No camera on the market today shows the temperature of the heat waves or atmosphere above you. They only show the surface temperature of an object. As an example, let's say you're operating in a structure and someone opens the door to the fire room. Your tick would show active heat waves rolling above your head. However, the temp gauge would only show what the surface of the material on the ceiling has had time to heat up to, not the over 1,000 plus degree flammable gases above your head. Your tick comes with a training video on the basic operation and care of the camera. Here are a couple of points about indicator lights. The system status light is solid green in normal operations. In the older cameras, it will flash, indicating it is in the battery saver mode. In the newer 5200 HD cameras, the green light is on, but you need to look at the bottom center of the screen, as pushing the green button will toggle it between the 2x zoom and a normal screen. 2x zoom while scanning reduces the field of view profoundly and makes it very difficult to scan. This feature is used to take a closer look at something of interest, not to scan. As for the battery, it should be solid green when you turn it on, indicating a full charge. Important things to be aware of are the red solid light, meaning that less than 15 minutes of operation remains. More importantly is a flashing red light. At this point, if you are not oriented in the structure, you need to get oriented right away because the camera is going to shut off in less than 1 minute. The overtemp typically occurs when the camera is handed off multiple times between different crews going back into a structure. This type usage doesn't allow the camera to cool down. Once it begins flashing, it's going to shut itself off to save the camera if it isn't cooled down immediately or removed from the hot environment. Different literature and training programs break down 5 areas of concern when using or relying on a tick. It is imperative that you pay attention to these 5 areas. The first one is the same as searching without a tick, standing and walking. If you can't see your feet, crawl. If you are walking instead of crawling, you can trip over objects you missed with your scan. Your crew most likely cannot see the things you can and may also trip over those items. Rollover and flashover occur up high where you would be walking. There is better visibility when you are low on the ground. When the floor is failing, crawling distributes your weight better, as well as gives you the ability to feel a change. You can search more area crawling and sweeping the area than you can walking and shuffling your feet. If the flooring is all the same material, you won't be able to tell the difference between a landing or a stairway with your tick. Remember, the thermal imager gives you the ability to see. It did not, however, remove any of the dangers present, or if anything, have gotten worse with the products that are burning in today's fires. Always, always, always use a standard search method. Your ability to see with a thermal imaging camera can allow you to move well into a structure only to have the camera fail or something knock it from your hand. If you have not stayed oriented, you may now be a mayday. Stay oriented to a left or right wall search. Use a hose line or a rope. Always locate a secondary means of egress as you move through a structure. The thermal imager will allow you to look around to see doors and windows that can serve that purpose. If for some reason the thermal imager fails, you still will need to continue to search. If you have not stayed oriented, that will not happen and your focus will be on saving yourself. Speed works in 2 ways. A tick can allow you to proceed quickly, or it can actually slow you down. Let's talk about the first, too fast. Now that you can see, you are able to move through a structure very quickly. This newfound ability creates several problems. If you move too fast and too deep into the structure, have you been monitoring your air? Do you have enough air to exit if your tick fails? Was your crew able to see what you can, or did you leave them in the dust? Now you may find yourself alone, and they may also be lost in a building without a camera. Both situations could trigger a mayday. So how can a tick slow you down? This generally occurs to users who have not had a great deal of practice. The ability to see in smoky conditions makes it very difficult to put the camera down. New users want to overanalyze what they can see. With practice, you learn to scan, decide what needs to be done, put the camera down, and get moving. Practice is the answer so you don't find yourself misinterpreting what you're looking at. We have all been told white is hot and black is cold. Next time you train with your thermal imager, put your hand on the wall for a few seconds and take a look at what the tick displays. It's white, so it must be hot, right? What the camera is telling you is that your handprint is the warmest thing it sees, but it does not mean it's hot. When we practice at the station, we look at each other. What color is human skin? We are the hottest thing it sees in an air-conditioned room, so at almost 100 degrees, the human skin is white. Again, our training provides us with information, however, we may be misinterpreting it. We practice looking at each other in the air-conditioned station. Suppose you're assigned to primary search for a fire victim that is in or near the room of origin. Will they look like your crew sitting in a chair across the table from you, or are they now cooler than the rest of the room? If you are a RIC and looking for a firefighter down, what color should you be looking for? What will they look like if a fire sprinkler is activated and has wet everything, including the firefighter? Will they look like all the firefighters you have observed in the bay during training or standing outside the burn building? Get used to looking for shapes: a hand, a foot, a shoe, a helmet. These are the things that make the use of the imager a success. Our thermal imager is much like our eyes. Neither can see through walls. Our eyes can only see the surface of objects, and that is all the tick can do. It cannot see through walls, windows, or underwater. If you're looking at a shiny surface like stainless steel, polished marble floor, glass, mirror, or shiny paint, you can see a reflection of an object off it. A blanket will hide the heat signature of a victim underneath. The temperature reading is only the surface temperature, not the true temperature of the hot gases overhead. The only way to overcome these 5 safety issues is with training. Take the camera with you as much as possible. Learn what is normal so that when you see something out of the ordinary, most times that's what needs further investigation. Before we go in, we want to make sure the thermal imager is working correctly. Turn it on, check the battery, look at your hand or your partner. Is everything okay? If not, don't use it. If you think you may need it, take an extra battery with you. And make sure the zoom is not on. Our eyes have a very broad field of view. As such, your peripheral vision is much greater than what a tick allows you to see. Think about what you see when you take a picture with your cell phone or a regular camera. Couldn't your eyes see a much broader view of the same image? This is the reason why it's imperative that you move the camera from shoulder to shoulder to assure you don't miss anything. If the camera freezes during this scan, just back up to the point where it froze, or you could miss some very important things. When we start our scan with our tick, we want to first check the ceiling. This is information for our well-being. We can see the structural components, perhaps a drop ceiling, lightweight truss, or something else. Is there any deformity to the ceiling or its components? Is there an indication of heat conditions above our head? If we see any heat waves, which way are they coming from? Once the ceiling is done, drop to chest height and scan back the other way. This will provide room layout, size, egress points such as doors and windows, the location of furniture, and may locate a victim. Again, drop the camera down to the floor and scan back the other way. You are looking for victims, furniture, holes in the floor, or perhaps heat conditions underneath you and your crew. Here, as we previously discussed, start by looking at the ceiling level or tops of doorways to see what kind of heat buildup we have, as well as what the ceiling is made of. From our training with fire behavior, we know that the energy released from a fire will go up until it hits something, typically the ceiling, and then roll in a direction away from the fire. These waves provide information as to the direction of the fire and also the possible size of the fire. As we discussed before, our training may have set us up to misinterpret information. Let's take the case of a firefighter. We typically look at each other in our PPE, but without any obstacles. Here behind the pallet, we can make out the shape of a firefighter, much different than what we're used to seeing. Learn to look for shapes with your tick. This is more than likely what will lead you to your target. So here we are looking for something that doesn't fit, something unusual. Let's take the case of a smell of smoke in a building. If you suspect the air conditioner, use your TIC to look at several of the vents. First off, based on what we have learned, what color would the vent and surrounding ceiling be if the air conditioner is working correctly? That's right, it would be black because it's the coldest thing in the view. Now back to our smell that you think is an AC issue. If you see that the AC vents are black, but in another room they are white, what doesn't fit? If you locate the air handler for the white ones, odds are something happened that is making it not blow cold. Is the AC hot, or is it simply warmer than the surrounding surface? The temperature feature of the TIC can help you with this. Don't look at the cover on the AC handler and think all is well. You can't see through the metal with your TIC, and unless it has heated up the cover, you will need to remove it to look inside to see if something is wrong. Here we have a firefighter in a room that was on fire. Why is the air bottle black? That's easy, it's the coldest thing in the room. If you were a Rick looking for a firefighter in a building on fire, would you expect to find something cold in that environment? This is unusual or an out-of-place item. This might be the first thing you want to check. Practice as much as possible so you can recognize when something is unusual. As we discussed before, when we talked about the speed, this is the technique that best lets you utilize the TIC and save a considerable amount of time. Perform your scan shoulder to shoulder, ceiling, chest, and floor, then decide what it is you need to accomplish. Put the camera down and get moving. You can bring the camera back up when you need to, but don't stay attached to the screen. Otherwise, you will find that the whole process is slowed to a crawl. When you locate a victim, use the camera to locate a nearby means of egress to remove them quickly and resume your search. The basics of a search led by a TIC is no different than a search without one. We recommend the company officer with the camera remain the oriented person. The company officer would stay in contact with the wall, or they or a team member can remain in contact with a hose line or rope. The company officer would be responsible to not only maintain awareness of their location and additional egress points within the structure, but to direct the crew where to search, as well as use the camera to monitor any changes in conditions. Voice, vision, or touch are the three fundamental methods to stay in contact with your crew members during a search. Although a TIC can be used to keep track of your crew visually, it does not replace the vision component we speak about when we talk about a standard search. You must also practice maintaining voice contact with a team. If not, should the TIC fail, you and your crew may now be separated and perhaps lost. When we talk about a TIC-directed search, we are probably talking about conditions that do not allow you to easily maneuver through a structure. Conditions such as heavy smoke, unknown location of a fire, and no water. Typically the conditions you would expect to encounter during your primary search. This is the most important time if you're going to make a rescue. The need to quickly assess the situation and structure and get moving is of great importance. Decide what you need to do and put the camera down and get going. A TIC still has a place during a secondary search, but its greatest ability would be in the initial IDLH conditions. Primary means of egress, beds, closets, and hidden areas are the areas to concentrate on. With the TIC, if you can see it, don't spend any time searching it. When checking a bed, you absolutely positively need to check under the sheets or comforter, behind it and under it. Unless a person's body heat has conducted through the coverings, you will not be able to see through it to determine if someone is in that bed. This is why all beds get hand searched. Closets and hidden areas also need a hands-on search. Remember, if you're doing a search using your irons, to keep yourself oriented, keep the tool in contact with the wall, doorway, or window. Don't swing the tool into the room looking for the victim. If you can see it, don't stop. However, if the shower curtain or glass enclosure door is closed on the tub or shower, a closer look will be needed. For a bedroom, remember it is imperative that you put your hands on the bed and check under and on the other side, along with inside the closet and any areas behind furniture you cannot see with the TIC. Many of these we have discussed, but let's take a minute to review, as these are the things that without practice can land you in a bunch of trouble. If you find that you need to wipe your SCBA facepiece, typically after the hose line opens up, the same conditions limiting your view is occurring on the lens and screen of your TIC. We can't see underwater, and in some cases through heavy steam conditions. Water on a group of objects may cause an equal temperature of all, making it extremely difficult to determine what it is you're looking at. Remember your air and your crew when using a TIC. It's very possible to outrun both. Take a look at a chrome pot at the station when water is boiling in it. The imager will indicate that it is cold. Understand and accept it, but sometimes that's how it works. Any shiny surface will reflect an image. If you are searching and see a body on the floor or a fire across the room in a place such as a commercial kitchen with all the stainless steel, you will still need to check it out. Remember, if there is no one there or your hose stream is not putting out the fire, consider the angle. You're probably looking at a reflection. Another thing to be aware of is that water on the floor when viewed through a tick can look like a hole. However, if you had fire below you, you would expect to see a different color along with heat waves pushing up. If you're in a house being built, remodeled, or torn down and see a square or rectangular shape on the floor, be careful. It could be a mat or area rug, or it could be a hole for a stairway or other construction feature. Crawling in these low visibility conditions and using a tool or your outstretched leg to search would easily locate these holes before you fall in. There have been discussions of using an imager to see footprints to possibly determine where a child may be hiding or have gone. Keep in mind these are quick transfers of heat and very short-lived. However, in the case of a motor vehicle accident, let's say a rollover with an unconscious patient, and you want to determine how many people may have been in the car, look at the seats for a heat signature. That transfer of heat lasted much longer and as such would hold a heat signature longer. You must still do this very early on as that heat signature will dissipate over time. Consider this, just because you saw 2 heat signatures in a vehicle and only have 1 victim, it doesn't necessarily mean you're missing someone. What if they drop the other person off right before the collision? The color white only indicates it's the warmest thing that tick has to compare it to. It doesn't automatically mean it's hot. Thermal inversion tends to be a trick of the mind based on the way we typically train with a tick. Remember the part about misinterpretation. At the station, take something out of the refrigerator and put it on the counter. What color is it? Now take that same object and put it in the freezer. Why is it not black anymore? The reason is it's no longer the coldest thing in view. When we are used to observing a hose line used to extinguish a fire, you expect the water to be black as it's cold water in a hot environment. However, that same water from a decon shower is now white. Why? When you get used to looking at a human body in the station in air conditioning, what would you expect that same body to look like in a room exposed to fire? We get jaded by our expectations of what should be. The tick simply shows you an image. You need to translate that into usable information. Glass not only reflects your image, you also will not be able to see through a window or anything else for that matter when doing your 360 walk around. If heat has not conducted through an object, you will have no way of knowing what is behind or underneath it. One point to keep in mind is that in the event you find yourself in extremely thick smoke, if you can't see the screen on the tick, you can't see what it's showing you either. Drop back to a standard search, but also evaluate the conditions present and determine if you need to be in there. For us, the most dramatic use is for search and rescue. With a tick in hand, you can now see things that were not possible before. We think about its use in a fire because it gives us the ability to see, but consider locating a victim ejected from a vehicle or a lost child in the woods. These two are search and rescue uses that the tick is well equipped to handle. The trick is to remember to bring it with you. While doing your 360 walk-around scan with the tick, you may be able to locate electrical wires or a heat signature on a window or door even though you can't see through them. If there is heavy smoke or fog, you still can do the 360 and should be able to see the structure and perhaps the nature of the problem. For a major motor vehicle accident with fire and lots of smoke or in heavy fog conditions, the tick should give you the advantage of vision. One of the most important aspects for us is to allow the person with the tick to monitor the conditions to see if things are changing for better or worse. It allows you to monitor your crew. It allows you to locate additional means of egress for rapid exit as well as victim removal. In a smoky brush fire, you can see the location of the fire, trucks, and crews, all making it much safer for those working on the scene. Overhaul seems to be the most used aspect of our tick. It allows you to open only what needs to be done, thereby saving the homeowner damage as well as limiting additional damage that makes the investigation job much harder. In some cases, it will show you an area of concern that needs to be investigated that you may not have considered. You would be able to locate windows or doors from either the inside or outside, which could be used to form a flow path for your ventilation. On the roof, you may be able to locate the hottest spot on the roof or a hot vent pipe indicating heat in the area. Keep in mind the sun may cause the entire roof to show a heat image. Your interpretation of this information will need to be based on all conditions present. If you want to practice your hazmat skills, get a plate and put some cold water in it. Then pour a little bit of cooking oil on top. Because of the difference of temperature and the fact that the oil floats on the water, you would be able to see where your hazmat leak is, as well as where it may be going. In some cases, you can look at a container and see how much product is inside. However, if the tank is insulated or a double wall, this does not work. If the tank is sitting idle and the vapor space and liquid space are both the same temperature, you very well may not be able to see any difference. A gas leak may also be visible with your TIC, as it may be a different temperature than the surrounding air. Once again, practice and bringing the camera with you as much as possible will allow you to learn what works and what doesn't. Be aware our TIC is not intrinsically safe. As we talked about during your scan, look at the ceiling first. This will give you information on the type of ceiling and if there is high heat causing it to bend or deflect, indicating a pending failure. You can see the size and layout of the rooms. Doors and windows are visible. Heat buildup in another room may cause the wall to heat up and expose the structural components in that wall, while the other walls do not. Watching the ceiling to see where the heat waves are coming from can get the fire attack team to that room of origin quickly. Because of the colorization feature, our TIC makes seeing the seat of the fire very easy. Consider holding the camera in front of the nozzle person so they can see the exact location of the fire as well as where the hose stream is hitting. This program has been a review of some of the features, uses, and limitations of our thermal imaging camera. It is up to you to take it with you and practice at every opportunity. Remember, you must always practice the rule of air management as well as use a standard search method when utilizing a TIC. Thanks for watching. We are hopeful you will find this information useful as you use your thermal imaging camera.